Good morning, students. In previous class, that is class 1 for the chapter Atomic Structure, I already completed about the little idea about giving little idea about what is electron, proton, neutron, that is subatomic particle. Then Thomson's atomic model. Then Rutherford alpha scattering experiment and also Rutherford atomic model and drawbacks of Rutherford atomic model. That is today class 2 of the chapter Atomic Structure. I will try to complete, giving little idea about what we mean by atomic number, mass number, how to calculate the number of electrons, protons and neutrons. Next, in case of neutral atom and also in case of ion, then 2 to 3 fundamental terms, that is what do we mean by isotope, isobar, isoton, isoelectronic species, and what do we mean by electromagnetic radiation, its characteristics. Then some fundamental term, that is what is wavelength, wave number, frequency, velocity, relationship between them, and some numericals relating to it. So let us start one by one. First one is atomic number. Atomic numbers represented by symbol Z. What do you mean by the term atomic number? The total number of protons present or equivalent to the total number of electrons present in a neutral atom is known as its atomic number. I repeat again. The total number of protons or the total number of electrons present in a neutral atom is known as its atomic number. Mark that. The total number of protons or the total number of electrons present in case of a neutral atom is known as its atomic number. Next, we discuss another term, that is mass number. What is mass number? Represented by the symbol A. What do you mean by the mass number? The total number of protons and neutrons of an atom is known as its mass number. Mark that. The total number of protons and neutrons present in an atom is known as its mass number. The total number of protons and neutrons present in an atom is known as its mass number. Mark that. Symbolically, mark that. We represent it X, it is Z, it is A. This Z represent atomic number, A represent mass number. That means atomic number means number of proton or electrons Mass number means it is the number of protons and neutrons. It is X represent the element. For example, if I write sodium 1123, sodium 1123 indicates that 11 is its atomic number and 23 its mass number. That means total number of proton is equal to 11. Total number of electrons is equal to 11. Mark that. From this it is clear that total number of electrons is equal to 11. Total number of protons is equal to 11. And total number of neutrons, we know that the mass number is proton plus neutron. Proton plus neutron 23, neutron is equal to 23 minus proton. That means 23 minus 11 is equal to 12. So total number of proton is equal to 12. So in case of neutral atom, total number of electron is equivalent to total number of proton, and mass number minus atomic number give rise to total number of neutron. In case of ionic species, mark that. In case of ionic species means it may be a cation and may be anion. Mark that. Na plus O2 minus. These are the ionic species. One is a cation, positive ion. One is anion, negative ion. In case of positive ion, Na plus means sodium atom loses one electron. So in case of ionic species, no change in proton. There is only change in electron. So while calculating the number of electron, mark that. In case of cation, minus. In case of anion, plus the charge which gives the number of electron. In case of cation, as it is 1 plus, that means we know atomic number of sodium is 11, atomic number of oxygen is 8. 11 means atomic number of proton is 11. Since it loses one electron, 1 plus 11 minus 1 is equal to 10. This is the number of electron. And in case of anion, atomic number 8 means number of proton is 8. If it is neutral, number of electron is 8. As it is minus means gain 2 electrons, so total number of electron, that means 10. So in case of ionic species, for cation, you have to minus the total number of charge, and in case of anion, you have to plus the total number of charge in order to get the total number of electrons. So it is all about atomic number and mass number, how we represent, that is symbolically represent an element. Next we go to another term. 2 to 3 term is there. What do we know? Isotope, isobar and isotope. Next we should go to another one term, that is isotopes. That is, what do you mean by the term isotope? That is, same element having same atomic number but different mass number. Mark that. Same element having same atomic number but different mass number is known as isotopes. For example, if we select for hydrogen, H11, H12, H13. If we select carbon, then C612, C613, C614. If we select oxygen, 816, 817, 8, 18. Similarly, if we select uranium, U92 to 35, 92 to 36, 92 to 38. If we select chlorine, chlorine 17, 35, 17, 37, 7. So many examples are there. These are comes under isotopes. Same element, same atomic number, but different mass. Next we switch over to another term, that is isobar. Next term is isobar. What do you mean by the term isobar? Mark that. Next term is isobar. That is different elements having different atomic number, but the same mass number is known as isobar. Mark that. Different element. Obviously, different element means atomic number differ, but mass number remains same. Then these are known as isobar. For example, potassium, argon, calcium, 1840, 1940, 2040. Mark that. Different element, obviously different atomic number, but mass number remains same. So it is an example of isobar. Isotope, isobar. Next, isotone. Next term is known as isotone. Mark that. What do we mean by isotone? That is different elements having different atomic number, and different mass number, but having same number of neutrons are known as isotopes. Mark that. Different element having different atomic number, different. If element are different, then obviously atomic number differ. Different mass number also, atomic number differ, mass number differ, but having same number of neutrons are known as the isotones. Suitable examples of isotones are carbon, nitrogen, oxygen. Carbon, nitrogen, oxygen. That is C12. 13. Oxygen is carbon C6, 12. Nitrogen 7, 13. Oxygen 8. For the mark that, suitable examples are there. Carbon, nitrogen, oxygen. That means carbon 6, 14. Nitrogen 15. It is 16. Carbon isotope. It is 14. It is 15. It is 16. Mark that atomic number differ, mass number also differ. That means here number of neutron is equal to mass number minus atomic number. 8 is equal to 15 minus 7, 8. 16 minus 8 is equal to 8. Mark that. The total number, atomic number differ, mass number differ, but the total number of neutron remains same. That means 8. So these are known as isotones because atomic number differ and mass number differ. So isotope, isobar, isotone. Next, another one term is there, that is isoelectronic species. Next term is isoelectronic species. Next is isoelectronic species. Iso means same, electron means electronic means electron. The species, it may be atom or may be ion, it may be cation or may be anion, having same number of electrons is known as isoelectronic species. The species, that is atoms or ions, may be cation or anion, having same number of electrons are known as isoelectronic species. It may be neutral atom, it may be cation, it may be anion, but having same number of electrons, then these are known as isoelectronic species. Mark that. For example, nitrogen, oxygen, N3 minus, O2 minus, F minus, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, etc. Mark that. Here atomic number, here the total number of electrons. Total number of electrons is equal to atomic number 7 gain 3, 7 3 10, atomic number 8 gain 2 electron 10, atomic number 9 gain 1 electron 10, it is neutral 10, it is atomic number 11 loses 1 10, atomic number 12 loses 2, atomic number 13 loses 3. So in each case the total number of electron is 10. That means these are known as isoelectronic species. That is, atoms or ions having same number of electrons are known as isoelectronic species. So we complete the few fundamental terms. That is, what do we mean by isotopes, isobar, isotones, and isoelectronic species. Next we discuss about another one fundamental term, that is what do we mean by electromagnetic radiation. Next we cover another one term, that is known as electromagnetic radiation. Next we discuss about electromagnetic radiation. So what do we mean by the term electromagnetic radiation? These are the energy radiation. Electromagnetic radiation, these are the energy radiation which do not need any medium for the propagation. That is UV ray, IR ray, X-ray. These are the energy radiation which do not need any propagation, any medium for the propagation. And these radiations are generated, these electromagnetic radiation are generated by the oscillation of a charged body in a magnetic field, by the oscillation of a charged body in a magnetic field, or by a magnet in an electric field, and which moves, and these radiations move, that is associated with travel, and these radiations move, do not need any medium and travel with the velocity of light. I repeat again, these are the energy radiation, mark that. These are the energy radiations, that is X-ray, ultraviolet ray, cosmic ray. These are the energy radiation, that is X-ray, UV ray, cosmic ray, which do not need any medium, which do not need any medium, which do not need any medium for propagation, and which are generated for propagation and which are generated by the oscillations of magnetic, these are the energy radiation which do not need any medium for propagation, which are generated by the oscillation of charge body in magnetic field, oscillation of charge body in magnetic field, or a magnet in electric field, which are generated by the oscillation of charge body in a magnetic field or a magnet in electric field associated with them and travel with the velocity of light. I repeat again. Electromagnetic radiation, particular characteristics there. These are the radiation which do not need any medium for the propagation and which are generated by the oscillation of a charged body in the magnetic field or magnet in the electric field, and they travel with the velocity of light. Next we discuss another fundamental term, that is, what do you mean by wavelength, frequency, velocity, relationship between wavelength, frequency, velocity. Next, wave number and amplitude. Mark that. Next, we discuss one fundamental term. One is known as wavelength. Symbol is lambda. Mark that. This is known as crest. This is known as trough. So, the distance between two nearest crests or the distance between two nearest trough. Mark that. The distance between two nearest crests or the distance between two nearest trough is known as wavelength, length of a wave, which is represented by the symbol lambda, and generally it is expressed in suitable, that is angstrom unit. That is 1 angstrom is equal to 10 to the power minus 8 centimeter is equal to 10 to the power minus 10 meter. That is, I repeat again, the length of a wave is known as the wavelength, which is represented by centimeter, meter, picometer, nanometer, angstrom, different one, but frequently we use angstrom unit. Next is frequency. Next term is next we discuss the second term, which is known as the frequency. Next we discuss what is wave. Next we discuss what is frequency. That is, frequency is nothing but the total number of waves passing through a point in 1 second. Mark that. Symbol is nu. It is defined as the total number of waves passes through a point in 1 second. It is represented by the symbol nu. It is represented by the symbol nu and it is measured in, it is expressed in cycle per second, that is CPS or hertz, 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 that is HZ, or simply reciprocal of second. Mark that is 1 CPS, 1 cycle per second is equal to 1 hertz. Mark that. Frequency is defined as the total number of waves passes through a point in 1 second. The number of waves passes through a point in 1 second. It is measured in terms of CPS, cycle per second, or hertz, or simply reciprocal of second. It is known as the term frequency. Wavelength, frequency, then the term is velocity. Next is velocity. That is velocity. The symbol V. The distance traveled by what is known as velocity? The distance traveled by a body in 1 second. It is defined by the distance traveled by a body in case of here wave, distance traveled by a wave in 1 second is known as its velocity. As we discuss about electromagnetic radiation, here we focus to the wave. The distance, that's why the distance traveled by wave in 1 second is known as its velocity. Next we discuss that is relationship between wavelength, lambda, frequency, nu, and velocity, that is V. This is the most important one. What is the relationship between wavelength, frequency, and velocity? That means velocity relation is velocity is equal to wavelength lambda into frequency. That is V is equal to nu into lambda, or lambda is equal to V by nu, or that is nu is equal to V by lambda. Mark that. The relationship are velocity is equal to wavelength into frequency. From this relationship, one is calculated the velocity if other two are given, one is calculated wavelength if other two are given, one is calculated frequency if other two are given. Let us apply this formula, let us apply this relationship to solve one or two problems. Mark the question. What is the question given? That is, calculate the frequency. Two questions are there. Calculate the frequency of light radiation having wavelength given. And second question, the Vividha Bharati station of All India Radio, Delhi broadcast at a frequency given this much. Calculate the wavelength. Question is wavelength of electromagnetic radiation. So we solve first second, then we solve to first one. Answer. Mark that. Answer. What are the data given? Given that. What are the data given? The frequency that is nu given is equal to 1368 kilohertz. That is equal to 1368 into 10 to the power 3 hertz. It is given. Next is another one, light radiation. We know the velocity. We know velocity of light radiation v is equal to 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second. Or if we transfer to into second, 3 into 10 to the power 8 second per centimeter per second, not necessary. Then question is calculate the wavelength. Lambda is question mark. Mark that. Frequency given, velocity given. We have to calculate lambda. We know what is the relationship. Velocity is equal to wavelength into frequency. That means wavelength is equal to velocity by frequency. Putting this value, mark that. Putting this value, that means wavelength is equal to 3 into 10 to the power 8 meter per second divided by frequency 1368 into 10 to the power 3, that is hertz or cycle per second. Dividing this value, if we divide this one, then velocity divided by the frequency, then approximate value is equal to 219. Approximate value is 219.3 meter. It is the wavelength of. Calculate the wavelength of the electromagnetic radiation emitted by the transmitter. So it is the answer. Move to the next question. Mark that. First read the question, then write down what are the given data, put this data in the formula, get the answer. Mark that. Frequency, calculate the frequency of light radiation. Mark that. Given that velocity of light radiation, velocity 3 into 10 to the power 8 meter per second or 3 into 10 to the power 10 centimeter per second. Next one is wavelength. That is lambda 6000 into 10 to the power 6000 angstrom is equal to 6000. We know 1 angstrom is equal to 10 to the power minus 8 centimeter. This value is there. Question is frequency. We know that velocity is equal to frequency into wavelength. So frequency is equal to velocity by wavelength. Velocity, that is 3 into 10 to the power 10 centimeter per second divided by wavelength 6000 into 10 to the power minus 8 centimeter. Mark that. On solving this value, answer nearly equal to 5 into 10 to the power 14 second inverse. Mark that. On solving this value, answer is 5 into 14 second inverse. Either you write hertz, or you write cycle per second, or you write simply second inverse. These are the one or two problems relating to the relationship between wavelength, frequency and velocity. Next we switch over to another two term, that is known as wave number and that is known as amplitude. Next we discuss about another term that is known as amplitude. Next we discuss amplitude symbol A. Mark that if it is a wave, then it is the maximum height of crest, it is the maximum depth of trough. So amplitude is nothing but the maximum height of crest and maximum depth of the trough is known as amplitude. Mark that it is defined as the maximum height of crest or the maximum depth of trough, and it is denoted by the symbol small a. It is known as the term amplitude. Next, another one term is there, that is wave number. Next, that is wave number represented by mu bar. It is defined as the total number of wavelength per centimeter and is equal to normally the reciprocal of wavelength. Mark that. It is defined as the reciprocal of wavelength. It is defined as the reciprocal. It is defined as the reciprocal of wavelength, and normally it is the number of wavelength per centimeter. Normally it is the number of wavelength per centimeter. The number of wavelength per centimeter, and is defined as the reciprocal of wavelength is known as wave number, that is mu bar is equal to 1 by lambda. These are some frequently appearing the term. Next, we should go to another one is there, that is next term is after the wave number we discuss about another one term that is known as electromagnetic spectrum. Mark that. Next term is electromagnetic spectrum. Electromagnetic spectrum. What do you mean by electromagnetic spectrum? If the energy radiations are arranged in a order, that means in increasing order of their wavelength or decreasing order of their frequency, then this arrangement is known as electromagnetic spectrum. I repeat again, electromagnetic spectrum is defined as the arrangement of various types of electromagnetic radiation. Mark that. It is defined as the arrangement of different types of electromagnetic radiation. It is defined as the arrangement of different types of electromagnetic radiation in order of their increasing wavelength. In order of their increasing order of wavelength or decreasing order of their frequency. That is increasing order of wavelength. If we arrange the different energy radiation, that is UV ray, X ray, IR ray, that is cosmic ray, visible ray, all the energy radiation, if we are arranged in the increasing order of wavelength or decreasing order of frequency, then this arrangement is known as electromagnetic radiation. Mark that. If we arrange, first one is cosmic ray, then gamma ray, then X-ray, cosmic ray, that means it is increasing order of wavelength, or one can say decreasing order of frequency, cosmic ray, next gamma ray, X-ray, ultraviolet ray, next visible ray, cosmic ray, gamma ray, X-ray, ultraviolet ray, visible ray, IR ray, infrared ray, infrared wave, and last one is that is known as radio, microwave. Another one is also there, microwave, and last one is radio waves. Last one is radio waves. I repeat again. That is cosmic ray, gamma ray, X-ray, ultraviolet ray, visible ray, IR, infrared, microwaves, and the last one is radio wave. It is the arrangement of increasing order of wavelength or decreasing order of frequency. This arrangement is known as electromagnetic spectrum. Next we discuss about Planck's quantum theory of radiation. Next, Planck's quantum theory of radiation is a very important one for exam point of view. Max Planck gave some theory, and according to him it is known as Planck's quantum theory of radiation. The various postulates of Planck's quantum theory of radiation is that the energy is emitted or absorbed. 3 to 4 points are there. We discuss one by one. The energy is emitted or absorbed by a body is discontinuously in the form of a bundle or packet. I repeat again. Energy emitted or absorbed by a body discontinuously in the form of packet or bundle. That packet of energy or bundle of energy, is known as quantum. In case of light, that energy bundle is known as a photon. The energy may be from any source is there, then it is known as quantum. If that energy bundle related to light, then it is known as photon. And next point, the energy that is emitted or absorbed is directly proportional to the frequency of radiation. That is, E is the energy, nu is the frequency, E proportional to nu, or E is equal to h nu. That is a small letter h is a constant known as a Planck's constant. Its value is 6.625 10 to the power minus 27 or second, or 6.625 into 10 to the power minus 34 joule second. That is E is equal to h nu. Last point is that energy emitted or absorbed by a body, that is integral multiple of a whole number multiple of h nu. That is E is equal to mh nu. That means a body can emit or absorb 1h nu, 2h nu, 3h nu, but not 1.3h nu or 2 by 3h nu, neither decimal nor fraction. It is the integral multiple, whole number multiple of h nu. So let us discuss again, write the point one by one. That means the various postulates of Planck's quantum theory. That is, point 1, the energy emitted or absorbed by a body, discontinuously in the form of a bundle all small packet going to each packet of energy, each bundle of energy is known as quantum, and if it is related to light, then it is known as photon. If that energy bundle related to light, then this energy bundle is known as the photon. Unless any other energy bundle or a packet of energy bundle, that is known as quantum. That means each packet of energy is known as quantum, and if that energy bundle related to light, then it is known as photon. Next, the amount of energy associated. The amount of energy associated with that packet of energy associated with photon is directly proportional to its frequency of radiation. That means E proportional to nu, or E is equal to h nu. Mark that. This energy bundle is associated with the energy. This one is directly proportional to the frequency of radiation. If we remove the proportional sign, leave the equivalent constant, that is known as small h, known as Planck's constant, whose value is nearly equal to 6.625 into 10 to the power minus 27 or second, or 6.625 10 to the power minus 34 joule second. Mark that. Where h is known as Planck's constant, and its value is equal to 6.625 10 to the minus 27 or second, or is equal to 6.625 into 10 to the minus 34 joule second. E is equal to h nu. Then last one is energy absorbed or emitted in the integral multiple of h nu. Next, last point is, that is the total energy emitted or absorbed by a body. Last point, the total energy emitted or absorbed by a body is a whole number multiple of h nu. That is E is equal to mh nu, where n is equal to 1, 2, 3 ... So from this point it is clear that body emit or absorb discontinuously either 1 h nu, 2 h nu, 3 h nu, but not 1.2 h nu, 3.4 h nu or 3/7 h nu. These are the various postulates of Planck's quantum theory. Now let us solve one or two problems related to the relation. That means the formula E is equal to nh nu. Mark the question. What is the question? Which has higher energy? A photon of red light having a wavelength 7,500 angstrom, or a photon of green light with wavelength is 5,250 angstrom. Which has higher energy? Mark that answer. We know that the relationship is equal to E is equal to h nu. We know relationship, that is E is equal to h nu. And if frequency is not there, then we can replace E is equal to hc by lambda. Mark that. Here C is constant, H is constant. So energy is inversely related to wavelength. That means that energy, that one possesses higher energy whose wavelength is lower. Mark that. That is red light wavelength 7500 and green light wavelength 5250. Since energy is inversely proportional to wavelength, so lower the wavelength, higher the energy. That means since wavelength of green light is lower, therefore its energy is higher. Mark that. E is equal to H2 or sometimes we can apply the relationship E is equal to NH2. 1, 2, 3, 4. 4 parameters are there. 3 parameters given. We have to calculate the fourth one. Sometimes N is given, H is always the variable parameter is the frequency. If the frequency is not given, we can write E is equal to NHC by lambda. Mark that. C, velocity of light always fixed, H is fixed. So depending upon the data, we have to select which formula we have to use in this question. It is all about the Planck's quantum theory of radiation and some numericals relating to it.